Hi everyone! Today we are going to be talking about temperature, specifically how temperature relates to the motion of particles. As we go through the notes today, please keep in mind the notes that we took the other day on the motion of particles, specifically when it comes to temperature. The first thing I want to talk about is the units for temperature. I know you are automatically going to want to use degrees Fahrenheit. However, this is a chemistry class, so we are not going to be using degrees Fahrenheit. Instead, we are going to be using degrees Celsius as well as Kelvin. Let's talk about degrees Celsius. Degrees Celsius is all about water. Water freezes at 0 degrees Celsius, and water boils at 100 degrees Celsius. The temperature between these 2 points is divided into 100 equal pieces. You can definitely have lower temperatures than 0 degrees Celsius. They're just negative, just like in degrees Fahrenheit. In lab, we will be recording in degrees Celsius, so please do not write Fahrenheit, even though you will want to. Remember, the higher the temperature, the hotter the substance. The hotter the substance, the faster the particles move. Okay, so remember, when a solid is heated, it becomes a liquid. When a liquid is heated, it becomes a gas. When a gas is heated, the particles move faster. Every one of these takes up more and more volume. Now let's talk about Kelvin. You don't normally see Kelvin in the everyday world. I don't even know if you've seen Kelvin until right now. But Kelvin relates directly to particles. Water freezes at 273 Kelvin. It boils at 373 Kelvin. Notice I didn't say degrees. There is no degree sign with Kelvin. There is a 100-degree difference between the freezing and boiling point of Kelvin. This is the same size of degree in degrees Fahrenheit. They are both 1. So everything between 273 Kelvin and 373 Kelvin is by units of 1, and 0 degrees Celsius to 100 degrees Celsius is units of 1. So this makes it fairly easy to convert. It actually makes it very easy to convert. Kelvin is not based on the freezing and boiling of water, but on the motion of particles, like I said. The slowest particle you can get is one that is not moving at all, which is not very often. That is 0 Kelvin. This is when particle motion stops. This is equivalent to negative 273 degrees Celsius. You can't have a particle slower than when it is stopped, so there are no negative Kelvin temperatures. Another word for 0 Kelvin is absolute 0. So when we talk about absolute 0, we are talking about 0 Kelvin. Now let's talk about converting between Celsius and Kelvin. Like I said, it's pretty easy. When we are going from Celsius to Kelvin, we just add 273. 0 degrees Celsius equals 273 Kelvin. So to get from Celsius to Kelvin, you just add 273. When you are going from Kelvin to degrees Celsius, you subtract 273. Remember, if you want to double check yourself, degrees Celsius will always be smaller than Kelvin. Let's look at an example. If a room is 23 degrees Celsius, what is its Kelvin temperature? So, you take 23 degrees Celsius, you add 273, just like we previously stated, and you get 296 Kelvin. The last thing I want to mention is temperature is a measure of the average kinetic energy, or the motion of particles in a substance. So remember, higher temperature equals more motion, or kinetic energy. Lower temperature equals less motion, or less kinetic energy. Higher temperature means faster particles, means greater kinetic energy, and vice versa.